Schmidt portable blasting equipment. Our standard sizes are 1.5, 3.5 as seen, and 6.5 cubic feet. This unit specifically is a non-pressure hold system that consists of an original Schmidt combo valve, the original Schmidt micro valve 2, Schmidt's G2 pneumatic deadman, and our VBS blowdown system, volumetric blowdown suppression. These units are engineered and manufactured to give you as little pressure drop across this system as possible. Remember that the lower the pressure drop across your equipment, the more pressure you have at the nozzle, increasing your productivity. The non-pressure hold system works like this. I have an air inlet which is supplied from your compressor, hopefully through some type of moisture extraction method. Nonetheless, this is your air supply to the vessel, where your air is brought in. It comes through an inlet ball valve into this moisture separator. It's set on a tangent such that it creates a cyclonic effect of the air inside this moisture separator, which spins out any of the condensate that may be in your air supply. Once it comes out of your moisture separator, it enters into the base of the combo valve, where it is stopped by a urethane plug assembly on the combo valve. The combo valve is currently at rest, therefore I have air to my moisture separator feeding air to the base of my combo valve. Your orange line of the deadman is connected to the base of the combo valve so that it feeds air to your pneumatic G2 deadman. Once the air gets to this pneumatic deadman, the air is actually stopped by a mechanical valve inside this deadman. When your operator depresses the lever on that deadman, he is transferring air from the orange line to the black line. The black line will follow around and come up to the piston chamber on the combo valve. Once that air enters the combo valve piston chamber, it will move the piston over, causing two effects. One of which is the combo valve plug assembly is moved off of its seat, allowing air from your moisture separator to come across, enter your vessel, pressurizing your vessel, and entering your pusher line, which comes down into the mixing chamber of the micro valve 2, where the abrasive from the vessel enters your airstream and goes out to do your work at your nozzle. Secondly, the combo valve moves over and pinches the blowdown hose off so that the vessel is sealed and can retain the air pressure that has entered it. Your operator is now in a blast function. When that operator has finished his job or needs to move, the deadman is released. A mechanical valve shuts the air off from the orange line to your black line. Then the black line is allowed to vent to atmosphere under this handle. The black line pressure is what's holding that piston over, opening the combo valve and pinching this blowdown hose. So once this black line is vented to atmosphere, the spring in the combo valve takes it back to rest, shutting your air supply off and opening the pinch on this blowdown hose, allowing the energy, the air from the vessel to exhaust to atmosphere through our VBS system. It reduces the noise and the intensity of the energy as it exits this vessel. Once your deadman has allowed your combo valve to go back to rest, all of the energy from your vessel exhausts to atmosphere through the VBS, your blast operation stops. The problem in our industry is how to contend with the intensity of these vessels depressurizing. This vessel has 150 psi, it has abrasive, it has dust, and when any control system allows that energy to go to atmosphere, it is with extreme intensity, with dust, with abrasion. At times it can be a safety hazard. Store-bought mufflers are not designed for this application. They have filtering elements in them. They can clog with abrasive, they can clog with moisture, they can retain vessel pressure, they can put a person in a dangerous situation. We designed this VBS specifically for this application. The way that we introduce the air into the VBS to a urethane target plate with the specialized materials that are in this vessel and the exhaust configuration that we have on our VBS have answered all of those issues specifically for this application. Another element of the microvalve 2 combo system, of course, is the microvalve 2, and its purpose is to regulate how much abrasive is allowed into your airstream at any point in time. This valve is very simple to operate. By turning right, you reduce the amount of abrasive allowed into your airstream. Going left increases the amount of abrasive in your airstream. One of the features on the microvalve 2 is our VPI, our virtual position indicator. That is what you see right under the handle. This orange decal is a direct reference to the orifice opening in the valve that allows the abrasive to flow in. So your operators come and get a visual aspect of how far that valve is, so he knows how much abrasive his operators are putting into their airstream while they're blasting. Another feature of the microvalve 2 is our cleanout port. This 1-inch pipe cap. When a foreign object is allowed into this vessel, clogging the orifice, stopping the abrasive flow into your air, your operators can simply remove this 1-inch pipe cap and reach inside and remove that foreign object without dropping the entire valve as other valves require you to do. So simply by opening this up, cleaning it out, and replacing that plug, your operator can go back to business and get his abrasive flow going again without having to empty the entire vessel. Pressure drop is an important factor to be understood in abrasive blasting. NACE, the National Association of Corrosion Engineers, did a study where they proved that for every 1 psi of blast pressure loss at the nozzle, you lose 1.5% productivity. Doesn't sound like much, but when you consider that a lot of systems will lose 10 psi at the nozzle, well, that's a loss of 15% productivity. The numbers are considerable. The Schmidt line of abrasive blasting equipment is designed to minimize that pressure loss as much as possible. We have done studies with a given air source, a given blast hose, and a given nozzle, where this equipment was measured from the inlet to the blast hose connection of having a loss of around 1.5 psi. Under those same characteristics, the same setup, competitors' equipment, we measured at a 14 psi loss. So the difference between our 1.5 and a competitor's 14, that equates to a 19 or 20% production loss. These numbers are large. We have to minimize that pressure drop to give you the maximum productivity possible out of this abrasive blasting equipment. Schmidt abrasive blasting equipment has the features to give your operators maximum productivity at the nozzle. Those features include the original combo valve, our VBS, our microvalve 2, and our G2 Deadman. These features combined give you the most reliable, productive, efficient blasting equipment in the marketplace. There are imitators. None are able to reach the productivity and reliability of original Schmidt equipment.